Hello dear students. Now today we are continuing the same Cauchy integral test, and we solve two problems. The problem one is this is well known problem. This is P series, and you have used this series in so many problems. So what is P series? The infinite series 1 upon n to the power p is convergent for p greater than 1 and divergent for p less than equal to 1. Prove it by using Cauchy's integral test. So here the given series is sigma 1 upon n to the power p, and un will be 1 upon n to the power p. Taken it as a function fn and find the integral 1 to infinite fx dx. So what is the value of fx? Fx will be 1 upon x to the power p. Now there are three cases: p greater than 1, p less than 1, and p is equal to 1. So first of all we discuss for p is equal to 1. So if we put p is equal to 1, then this term will be 1 upon x, and the integral of 1 upon x is log x with the limit 1 to infinite. When we put x as infinite, then this value log infinite, and at x is equal to 1, this is log 1. So log infinite is infinite and log 1 is 0. So finally it is infinite. So by Cauchy integral test, this series is not convergent for p is equal to 1. It means it is divergent. Now for p not equal to 1, if p is not equal to 1, then this integral will be x to the power minus p plus 1 upon minus p plus 1 with the limit 1 to infinite. So it can be written as like this. Now p not equal to 1, it means p may be less than 1 or p may be greater than 1. First we consider the case when p less than 1. So you can see here, if p less than 1, then 1 minus p will be positive, means power of x will be positive. So if power of x is positive, then the value of this term x is equal to infinite is infinite, and for x is equal to 1, it is 1. So finally it is infinite minus 1. So infinite minus 1 is always infinite, and the product of infinite with some finite quantity is also infinite. So therefore sigma un is divergent for p less than 1. Now we discuss the case of p greater than 1. So if p greater than 1, then you can see from here, if p greater than 1, then 1 minus p will be negative, means power of x will be negative, and if power of x is negative, then for x is equal to infinite, this term will be 0. So this is 0, and for x is equal to 1, it is 1. So finally it is 1 upon p minus 1, which is a finite quantity. So by Cauchy integral test, we can say this series is convergent for p greater than 1. I think it is cleared. Now we go to problem 2. A similar problem. Here series is given, n is equal to 2 to infinite 1 upon n log n to the power p. And same statement here, it is convergent for p greater than 1 and divergent for p less than equal to 1. You can see here this series start with 2. Why not with 1? Because if you put n is equal to 1 here, then this will be log 1 and log 1 will be 0. Then if this term is 0, then this whole term is infinite. So it means this term does not exist for n is equal to 1. So we start with n is equal to 2. Okay, so here un is this, taking it as a function fn, and find the integral 2 to infinite fx dx. this will be 1 upon x log x to the power p. Now you can see it is a simple integral because differentiation of log x is 1 by x and it is here 1 by x. So we put log x is t. Then 1 by x dx is equal to dt, and for limits of t, if x is equal to 2 then t is equal to log 2, and if x is equal to infinite then t is equal to infinite. So our integral will be log 2 to infinite 1 upon t to the power p dt. So similarly we discuss three cases here. First of all, for p is equal to 1, if p is equal to 1 then it will be 1 upon t and the integral is log t, simple. So you can see when t is infinite, log infinite is infinite. When t is log 2, then it will be log 2. So infinite minus something is infinite. So therefore it is also divergent for p is equal to 1. Now for p not equal to 1. So for p not equal to 1, this integral will be t to the power minus p plus 1 upon minus p plus 1 with the limits log 2 to infinite. And this term can be written as like this. Now p not equal to 1, it means p may be less than 1 or p may be greater than 1. So for p less than 1, so for p less than 1, same case is here. If p is less than 1, then 1 minus p will be positive and the power of t will be positive, and in this case if we put t is equal to infinite then it will be infinite. So final integral is infinite minus this, and you know infinite minus something is infinite, and the product of some finite quantity with infinite is also infinite. So therefore this whole term is infinite. So sigma un is divergent for p less than 1. Now last case, for p greater than 1. So I is equal to 1 upon 1 minus p. So when p greater than 1, so you can see from here, when p greater than 1, then the power of t will be negative, and therefore value of this term at t is equal to infinite is 0. And it is simple, when t is equal to log 2, this will be log 2 to the power 1 minus p. So finally you will see it is a finite quantity. Therefore this series is convergent for p greater than 1. Thank you.